Hello and welcome to our International Science, Technology and Engineering Expo 2020 project presentation. Our project is titled Novel Low Temperature Hybrid Lead-Free Solder Alloy. Our team leader is Associate Professor Dr. Arvina Afzan. Our team members are Ms. Hana Abdullah as well as Ms. Noor Haslinda binti Muhammad Muzni. We are representing Multimedia University for this exhibition. For our project, we are going to start by introduction and background, objectives, problem statement and knowability, followed by methodology, result utilization, and cost analysis. For introduction and background, a hybrid alloy means that creating an alloy that will have a better all-around combination of properties than the initial materials used to possess separately, which means if you're using tin and zinc to create a tin-zinc alloy, the tin-zinc alloy will have better property than tin on its own or zinc on its own. And to give you a background of the topic, after the prohibition of lead by the ROHS and many other legalization, lead-free soldering alloy became a highly sought-after research topic. And the answer to these researches was in the SAC alloys or SAC alloys, or in other words, tin, silver, and copper soldering alloys. And this became the most reliable or the number one option in the markets or in the research departments. This focus was due to the soldering alloy's superior mechanical properties, even though it had a relatively challenging melting temperature of the range up to 228. In comparison to the lead and tin solder, this temperature is quite high. It has also a reliable wetting and microstructure properties. Therefore, it was a good replacement at that moment. Nevertheless, these soldering alloys, they lack and they have many draws such as the high cost due to the content of the Ag in the soldering alloys, as well as a high melting temperature, as mentioned previously, a range up to 220 degrees Celsius. Objectives. Our objective is to develop and characterize the physical properties of SN9Z9% solder doped with aluminum oxide nanoparticle, and to study the strength and reliability of the nanoparticle reinforced composite solder with various weight percentage. Our problem statement and novelty. Up until today, the market of lead-free solder is still in search and in need for a good reliable lead-free solder that is a lead-free solder with a good melting temperature range and a reliable mechanical properties as well as cost-efficient at the same time. Hence, we decided to dedicate effort to study the nanocomposite hybrid lead-free solder that is based on SN9% eutectic lead-free solder. The nanocomposite means we utilize nanoparticle to enhance the property of the soldering alloy in a novel approach. This novel approach includes 0.1% of nanoparticles, 0.3% and 0.5%. Our methodology. Our methodology started by obtaining the raw materials, and as you can see in the photos, after we obtain the raw materials, we start by cutting, then measuring the raw materials. After that, this was followed by melting. We use a heating furnace for melting, and as you can see, after the heat treatment and after the solder alloy have been melted and mixed together, we extrude the crucible and we pour the solder in a surface that will help it not stick and be easy to remove later on. As you can see, this is the pouring process after the solder has been melted, and this is the initial specimen after pouring immediately. This is how it looks. After this, we move on to compressing to the lead-free solder to a thickness of 1 mm. After compressing, we punch into small billets. The billet's diameter is 4.8 up to 5 mm in diameter. We take these pellets and we use them for testing different properties of the solder to understand or to get a better picture of the capabilities and the properties of the solder. After conducting the testing on the billets, the results and the utilizations, we end up producing a lead-free solder that shows enhancement in mechanical properties as well as melting temperature not exceeding 140 degrees Celsius, which is a very low and a very good melting property. With all the efforts that we have done and with the result that we have obtained, all that is needed is to publicize the result through academic publication in order to help fill the gap in the market, which is one of the things we are trying to do through this exhibition as well. As for the cost analysis, we're gonna start by showing the price for the raw material. The price for the tin was $20 per kilogram. The price for the zinc was 2.54 plus dollars per kilogram. As you can see, it's a very cheap price. And the price for the aluminum nanoparticle was 39.37 per 10 grams. And we didn't utilize up to 10 grams in this project. After calculating all of these costs, the cost for the highest percentage we used, which is 0.5 percentage, the total cost for the composite alloy is 17.5 per 750 grams of the alloy. And as you can see, the price in comparison to the SAC 305 price, which is $120.66 per 750 gram, that the price is very cheap in comparison, which is a high advantage of the composite solder alloy we have produced. This will be all, and with this I will conclude our presentation. Thank you for listening, and we hope to hear good news from you soon.